Good morning, students. Today I am going to teach you integration 7.4 exercise question number 18. Please listen carefully. It is a very important question and थोड़ा सा लंबा है इंटीग्रेशन क्वेश्चन, तो थोड़ा ध्यान से सुनेंगे. इंटीग्रेशन 5x minus 2 upon 1 plus 2x plus 3x square. We can see that in the numerator there is a linear equation and in the denominator there is a quadratic equation. तो इस क्वेश्चन का फॉर्म क्या है? इंटीग्रेशन ऑफ px plus q upon ax square plus bx plus c. तो जब कभी भी हमें इंटीग्रेशन ऑफ लीनियर इक्वेशन अपॉन क्वाड्रेटिक इक्वेशन का फॉर्मेट मिले, you first see that if we take 1 plus 2x plus 3x square equals to directly t, और उसे t लेने के बाद after differentiation are we getting the numerator part? If we are not getting the numerator part, it means that you have to solve in this way format. Listen now. Numerator px plus q will be written, this is the formula, px plus q will be written as constant a into d by dx of the denominator ax square plus bx plus c plus b constant quantity. Every time when it comes such type of integration formats, you have to write linear equation equals to a into d by dx of the denominator quadratic equation plus constant. So in our given integration, our linear equation is 5x minus 2, ax plus q की value, a into d by dx quadratic is 1 plus 2x plus 3x square plus b. Now 5x minus 2 equals to a into differentiate 1 का 0, 2x का 2, 3x square का 6x plus b. Now you open this bracket, 2a constant plus b एक ब्रैकेट में रखिए और x वाला टर्म अलग कर दीजिए, 6ax. Now you compare LHS and RHS. Coefficient of x is 6a and coefficient of x is left side 5. So a is equals to 5 by 6. And now linear equation 2 variable constant, 2a plus b is equals to minus 2. Substitute the value of a which you obtain and get the value of b, minus 11 by 3. Question was our equation 1. After differentiation what you get, that is equation 2. And now after getting the value of a and b, you substitute this value of a and b in equation number 2. Systematic manner में problem solve करेंगे तो बन जाएगा. If you are going skipping up the steps, it will be difficult for you. So be careful. From equation 2, 5x minus 2, a is equals to 5 by 6, so 5 by 6, 2 plus 6x, and b is as minus 11 by 3, so it becomes minus 11 by 3. Now this 5x minus 2 numerator is equal to this term. This term I have to replace it now in equation number 1. Listen, from equation number 1, integration 5x minus 2 upon 1 plus 2x plus 3x square dx equals 2. Now 5x minus 2 is equals to 5 by 6, 2 plus 6x minus 11 by 3. This complete term you must write down in the numerator and the denominator you write down as such. 1 plus 2x plus 3x square. Now you split it up the two integrations. 5 upon 6 integration के बाहर, 2 plus 6x upon 1 plus 2x plus 3x square dx. अब कांस्टेंट की बारी, minus 11 by 3 इंटीग्रेशन के बाहर, integration dx upon 1 plus 3x square plus 2x plus 1 in the standard form we can write down. Now after this we are now having two functions to integrate it. First function, second function. The first function here it will become f dash x upon f of x the format. As we are differentiating this denominator, we will get this. I1 और I2 एक इक्वेशन बना लीजिए. क्योंकि एक साथ आप इंटीग्रेट करेंगे तो काफी लंबा हो जाएगा, you will get confused. So I1 you separately integrated, I2 you separately integrated, and then substitute the value of I1 and I2 in equation number 3. Let's see now. I1 2 plus 6x upon 1 plus 2x plus 3x square. We take this t, we get 2 plus 6x dx equal to dt log t log 1 plus 2x plus 3x square. We got the value of the first integration I1. Now we come for I2. Dx upon 3x square plus 2x plus 1. Now, as earlier I told you, in the integration of dx upon ax square plus bx plus c, the x square coefficient must always be equals to 1. But here it is 3. So we will divide out all the terms with 3. So 1 by 3 taken out, x square plus 2 by 3 plus 1 by 3. Now 1 by 3 dx, अब ax स्क्वायर प्लस bx को अपन एक तरफ रखेंगे अपने दिमाग में, एंड प्लस 1 by 3 leave out as a constant separately. To make it now as a perfect square, we have to add some constant value to this, so that it can become in the form of a plus b the whole square. So what I have given, discriminant must be equal to 0, b square minus 4ac equal to 0. Value of b is 2 by 3, so square 4 by 9 minus 4. Value of a will be always 1 into c equals to 0. c की value आ गई 1 by 9. So what I have to do, I have to add up 1 by 9 to this x square plus 2x by 3 plus 1 by 9, and plus 1 by 3 I have to subtract also that same term minus 1 by 9. This form a square plus 2ab plus b square, it becomes a plus b the whole square, x plus 1 by 3 the whole square, and 9, 3 minus 1, 2, 2 upon 9. 2 upon 9 can be written as root 2 upon 3 the whole square. Now it becomes integration of dx upon x square plus a square is tan 1 by a tan inverse of x upon a. So 1 by 3 it will be as it is. 1 by a root 2 by 3 is a, 1 upon root 2 by 3 tan inverse of x plus 1 by 3 upon root 2 by 3. You can take it x plus 1 by 3 as t also, and you can integrate it. But directly also you can do it. And 1 by root 2, 3 and 3 cancel out. 1 by root 2 tan inverse of taking LCM 3x plus 1 upon root 2. So we have integrated I1 also and I2 also. This I1 integration answer and I2 integration answer you substitute in equation number 3. So I equals to 5 by 6 log 1 plus 2x plus 3x square minus 11 upon 3 root 2 tan inverse of 3x plus 1 upon root 2 plus integration constant. So step by step you proceed, go through it, solve it by your own, and don't do any type of mistake in simplification. Slowly and slowly you do it. It is somewhat lengthy process, so be careful about it. Now let's move to the next question. Integration of 6x plus 7 upon under root x minus 5 x minus 4. We can split these two linear factors. X square minus 9x plus 20, multiply it, will get a quadratic equation. But now in this question there is a square root sign. In the previous question there was not a square root sign. Now it is of the form integration px plus q upon root over ax square plus bx plus c. So here also we have to apply the same formula. The linear equation equals to a into d by dx of ax square plus bx plus c plus constant b. Don't put square root sign. यहाँ पे square root sign नहीं आएगा. px plus q linear equation equals to a into d by dx ax square plus bx plus c plus b, and again we have to proceed in the same manner and we have to get the value of a and b, and that value a equal to 3 and b equal to 34. I have to substitute in equation number 2. So 6x plus 7 numerator will become 3 into 2x minus 9 plus 34. Now this value of the numerator function will be substituted in our question, equation 1. So 3 into 2x minus 9 plus 34. Now you split it out, I1 and I2. 3, 2x minus 9 under root x square minus 9x plus 20 plus 34 dx upon under root x square minus 9x plus 20. Now make it as 3i1 and 34i2. Now I1 we have to integrate in another space, and I2 we have to integrate in another place. So I1 2x minus 9 under root x square minus 9x plus 20. Here also if we take the denominator as a t, we will get the after differentiation 2x minus 9. So it will become dt upon root t. Previous question में क्या था, dt upon t log t बना था. But in this question it will become dt upon root t. So integration of 1 by root t is 2 root t, 2 into under root x square minus 9x plus 20. Now we move to the second integration I2 dx upon under root x square minus 9x plus 20. Same format, only the difference is that यहाँ पे square root sign आ गया है. At last the formula will be changing. So b square minus 4ac equal to 0. As we know that coefficient of x square is already here 1. So no need to divide it with any number. So 81 by 4 will be added to make it as a perfect square. That will become a minus b the whole square, x minus 9 by 2 the whole square. And to this 20 I have to subtract this number, as I have added up this number 81 by 4. So I have to subtract 81 by 4. So I got 1 by 4. 1 by 4 का square में लिखेंगे तो 1 by 2 का square. Now it becomes integration of dx upon under root over x square plus a square, which is formula is log x plus under root x square plus a square. So log x plus under root x square plus a square. If we will simplify this, we will get again x square minus 9x plus 20. From equation 4, 5 and 6. 5 और 6 का जो इंटीग्रेशन वैल्यू आया है, that we have to substitute in equation number 4. I equals to 6 times, as it is here 2 times, so 3 into 2 becomes 6 under root x square plus x square minus 9x plus 20 and plus 34. I2 is log x minus 9 by 2 plus under root x square minus 9x plus 20. So slowly and slowly, again I am telling you, step by step you proceed and simplify this problem. Now let's move to the next question. Question number 20. Integration x plus 2 upon under root 4x minus x square. Same as previous question number 19. Ex plus q under root ax square plus bx plus c. So x plus 2 linear equation numerator a into d by dx 4x minus x square plus b. In differentiation of 4x minus x square 4 minus 2x. Compare the coefficients of x and the constant values. You will get the value of a equals to minus 1 by 2 and value of b equals to 4. So now substitute in equation number 2. Value of a is minus 1 by 2, 4 minus 2x plus b is 4. Now from equation 3 you substitute in the question x plus 2 minus 1 by 2, 4 minus 2x plus 4 upon under root 4 minus x square dx. Separate the integration I1 and I2. I1 you take it as t and integrate, you will get 2 root t, and I2 you make it first here, this listen here 4x minus x square. So I am converting the value of a x square as positive. So I am taking minus common, x square minus 4x. Now I am playing b square minus 4ac equal to 0. I got the value which is to be added and subtracted as 4. So since I am subtracting here, there is a minus sign in front of it. So I have to add up 4 here, so it becomes 2 square minus x minus 2 the whole square. So integration of dx upon under root over a square minus x square is sine inverse of x upon a. So sine inverse of x minus 2 upon a is 2, and from equation number 5 and 6 the value of I1 and I2 I am going to substitute in equation number 4 minus 1 by 2. So this 2 will be now cancelled out. This when I am going to substitute this value, so this minus 2 under root 4 minus this 2 will be cancelled out. So here it is I1 and here complete. Here I am not going to write minus 1 by 2, sorry. Here also not minus 1 by 2. As I1 I am going to take it as, so I1 will be here equals to 2 root t. Just a slight mistake, 2 root t. So when I am going to substitute this value, minus under root this 2 and minus this divided by 2 will cancel out. So minus under root 4 x minus x square, 4x minus x square plus 4 I2 value sin inverse of x minus 2 upon 2 plus c, and that is our answer. In the same way, you can solve question number 21, 22 and 23, and that questions will be homework for you. So another important topic, integration by partial fraction. You can see partial fraction. If you want to study the various questions of the partial fractions, you can refer last 4 years back Navbodh textbook. In there is a complete first chapter of partial fraction. As you have studied proper fraction, degree of the numerator polynomial, if the degree of the numerator polynomial is less than the degree of the denominator polynomial, then it is known as a proper fraction. So, example, x plus 1 upon x square plus 5x plus 9, the degree of numerator is 1 and the degree of the denominator is 2. So, the degree of the numerator polynomial is less than the degree of the denominator polynomial. So, this is a proper fraction and we can proceed directly integration. When we are solving the integration by partial fraction, one thing you must, first of all, you have to see that whether the integration function is proper or improper. If it is proper, you can proceed directly. If it is improper, you have to convert first into proper fraction. So improper fraction, if the degree of the numerator polynomial is less than or equal to the degree of the denominator polynomial, then it is called a improper fraction. Improper fraction can be written as in class 9 we have studied the division of polynomials. In the same way, you have to divide both the polynomials, numerator and denominator, and both the polynomials you have to see that they both dividend and divisor must be in standard form. Okay, so after division you can write down quotient plus remainder upon divisor. This quotient single term will be integrated separately, and this remainder upon divisor, which becomes a proper fraction, will be integrated as we are integrating the proper fraction. Example, x square plus 1 upon 3x square plus 2x plus 2, both the numerator and degree polynomials are equal, so it is improper fraction. And x2 plus 1 upon x plus 1, the degree of the numerator polynomial is greater than the degree of the denominator polynomial, so therefore it is also a improper fraction. Now, page number 317, some of the forms are given and you have to write down. When this format is given, you have to write in this way, that you have to by heart it. So, if the denominator, I am talking only about the denominator. First, you have to see that all the fractions must be in the proper form. And then second thing, if the denominator, talking only about the denominator, is non-repeated linear factor means degree 1, non-repeated linear factor, then it can be written as, no need of writing down the linear equation, arbitrary constant upon the first factor x minus a plus arbitrary constant second one b upon x minus b, and then we have to solve it and get the value of a and b. That value of a and b we have to substitute here and we have to integrate the function. That I will explain you in next class when I am integrating such type of functions. Next, second, px plus q upon denominator. You can see here that here it is a repeated linear factor, 2 times it comes. If a single linear factor, only one linear factor is repeating twice, thrice, 4 times, then what you have to do? A upon x minus a plus b upon x minus a the whole square. If it is 3 times, then c upon x minus a the whole cube. But I will explain you while teaching the very short method of solving such type of question. So be careful in my next video. Third question, numerator is given quadratic. Now denominator you can see x multiplied, it will become x cube. So it is a proper fraction. So here also we can write a upon x minus a, b upon x minus b, c upon x minus c. There are 3 non-repeated linear factors. Then question number 4 you can see that x square हो जाएगा, यहाँ x हो जाएगा, x cube, it is a proper fraction. So here one of the factor is repeated and another factor is non-repeated. But here in the second and fourth, what is the difference? Here only one factor is repeated and no any other factor is attached to it. But here repeated भी है और एक non-repeated factor is also there. So first you can write a upon x minus a plus b upon x minus a the whole square, and then non-repeated linear factor as c upon x minus b. And the last fifth one, px square plus qx plus r upon x minus a, ax square plus bx plus c. Now here ax square plus bx plus c is a irreducible quadratic factor. It means that it cannot be splitted up into a linear factor by splitting the middle term. We can't factorize it. That also you have to be careful. If there is a quadratic factor in the denominator, suppose x square minus a square, it will be factorized, x minus a, x plus a. Okay, it can be converted into a linear factor. If it is x square plus 3x plus 2, it can also be splitted, factorized by splitting middle term x square plus 2x plus x plus 2. It can also be factorized and converted to a product of two linear factors. So be careful in such cases. If the denominator quadratic factor is not factorized by splitting middle term or by application of any formula or by taking common term, if it is not factorized, then only you have to write down. First is our linear factor, so a upon x minus a as such, and irreducible quadratic factor which cannot be factorized to further as a product of linear factor. You have to write down just above it the linear equation, general form, bx plus c upon ax square plus bx plus c. As earlier I told you that every fractions must be the proper fractions. So you can see that इसकी डिग्री 1 है तो ऊपर में कांस्टेंट आएगा जिसकी डिग्री 0. If I am going to take here bx plus c, it will become degree 1 and degree 1 will become improper fraction. So be careful. If it is a linear, you have to take a constant. If there is a here constant, everywhere you can see the constants are there and the degrees are 1. Here it is a repetition, no problem. But here you can see that the degree is 2. So degree 2 का general form ax square plus bx plus c, and the degree 2's previous degree will be 1, and degree 1 we are having linear equation in one variable. So that's why whenever in the denominator it comes a polynomial of degree 2, we will write down a polynomial of degree 1 in its numerator bx plus c. So all these definitions, examples, and these forms I will be going to discuss in the next video. So all these things, go through it step by step and write down in your fair notebook copy. Thank you.